Thanks for joining me. Appreciate that you showed up here today. I am going to be talking about threat modeling, a batch job framework, and this is based on a blog series that I started writing about 3 years ago, and then it sort of morphed from building batch jobs to help with security into how can we use, or how do we need to deploy the batch jobs, how can we make that secure, how can we run the batch jobs securely, so all those type of things, right? And so I'm just going to talk to you today about a little bit about what I thought about as I was writing this. And in each of my posts, I try to go through and talk about the threats and how I'm addressing them and the configurations. And I can't cover it all, so the main thing for this talk is going to be how I'm thinking about security, and that comes down to threat modeling. So the first thing is we have a lot of checklists in security everywhere we go. But security is not really checklists. Compliance is a checklist, right? And so how many companies do you know that are fully compliant with all their requirements and yet they're getting data breach? So there's my proof, right? Security is really an architecture. And architectures are not based on checklists, they're based on principles, right? And you have to put all those principles together correctly to build a good architecture that is secure. And one of the objectives for how you build that architecture is going to be based on a threat model. So you have these attacks that you're trying to defend against, and you're going to architect accordingly. So how do we learn how to build good architectures? Well, you read and listen and learn from a lot of great architects, such as Grace Hopper, who is famously the person who found the first bug in a computer system. It's a Navy system. And it was a literal bug. It was a moth. She talks about that in this presentation, which was recently released by the NSA. And it's super interesting how relevant a lot of that still is today. And there are obviously a lot of other great architects like Werner Vogels. If you go to AWS reInvent, my favorite presentation for our keynote is his keynote where he always has something technical in it. And last year's was particularly relevant to what I'm talking about because he went through what is a good architecture and how can you build one and what do you need to think about. And even says, like, I can't tell you exactly how to do it. Here's what you should be thinking about. So I would say go back and listen to every keynote from Werner Vogels. It's a great way to learn. So when we want to threat model something, first of all, we have to understand what we're building, right? And so a batch job is essentially a process, and it has some inputs, processes some data, and gives you some outputs. You can string batch jobs together, so you can have a job that produces an output, and that output goes into another job that produces some output, and then so on and so forth. Now, I don't have time to go over all of these. I did another talk on this topic in Mountain View, California earlier this year, and I'll include a link to that in these slides. But I'm going to talk to you about the first one, which is end of day. So I used to work for an investment bank, and banks will have this process called end of day, which runs at end of day. And it has to go through and it has to evaluate all the accounts and make sure everything's adding up correctly and before they roll to the next day and the new transactions come about. So some examples of batch jobs I worked on were like dividend processing. Every customer that has a security that paid a dividend needs to get their dividends. Not too many, not too little, it has to be right. And another one was interest on sweep accounts. So a sweep account is essentially a bank account that's associated with your security account. And the interest has to be paid that night, has to be right, it's calculated, add to the count, then they roll to the next day. A couple examples. One of the important things for a batch job, and there's a list here, don't have time to go over, but you can read it later, but each job can be independently verified for correctness based on its inputs and outputs. So if you think about financial transactions, you're putting something in, you're getting something out, it has to be right. So you want to make sure that's right. There's some other things here, like the logic of the order of the steps has to be enforced and things like that. So now I sort of reworked these slides a little bit to talk about AI because I've sort of shifted on my blog to writing a lot about AI and using AI. And I just basically realized, although I've been writing this about 3 years before AI agents were all the rage, an AI agent is essentially a batch job. So you have some inputs, and it's going to maybe use AI to figure out when to run the job, or maybe it's going to use AI in the job, or it's going to use AI after the job runs to call another agent. So there's lots of places where we can incorporate AI. And when you think about the AI, I just want you to remember one thing. It's a predictive model. So you're not going to always get those same inputs and outputs like I mentioned before. So when you're running some sort of batch job process or some agents that are calling other agents, you may have some sort of predictive model that's giving you something that's not consistent. And you probably don't want to use this for your end-of-day bank batch processing, right? So those are the things you want to be careful there. And that's essentially, so now let's go into some of the threat modeling. Now we know where we're going to build. When we're threat modeling, we have to understand how the attacks work. And a lot of you here are probably already security people that know this. But I do pen testing, and essentially I go and enter bad things anywhere I can. So that's going to be forms, that's going to be headers, cookies, URLs. I'm going to try to hit any open network ports. I'm basically trying to put bad things in there that make the system do things it's not supposed to and give me information. And when it comes to AI, that may be putting in a prompt that will let me get into something I wasn't supposed to get to through that model. There's been some other talks that are really interesting on that here this week. So when we're thinking about risk and how we reduce our risk when we're doing our threat modeling, the risk, I like to think about it as how many chances are you giving attackers? So you can think about all those different ways someone can insert data into your systems, and all of those things are potential risk. Obviously, if you can reduce some of those, you can reduce your risk, and you want to make sure you secure all those different avenues of attack. And then there are attack vectors, which are all the potential points of attack and the ways you can attack them. So for example, if I'm testing a website, I might try to do a cross-site scripting, insert some code, see if I can get it to respond to me. That's an attack vector. Then we have attack paths, which are the path to get to the vulnerability and then what you can get to afterwards. So once an attack gets onto a system, it might try to, the attacker's going to try to get from there into another system. And I have a tool that I wrote when I use on pen tests where I basically map out all the paths in a customer's AWS account on the network and say, okay, here are all the thousands of paths. If you could close some of those default outbound ports, you can limit what an attacker can get to and exponentially reduce your risk. How do we know what all the attacks are? Well, there's this thing called MITRE ATT&CK, for example, where they tried to have this taxonomy of all the different attacks. And AWS actually just came up with, in another talk I was listening to, AWS CERT came up with something like this for AWS. And I can't remember the name of it, but I will have it in these slides. But it's similar to this specifically to AWS, where it maps out the different kind of attacks they're seeing at AWS CERT. But that can be overwhelming, right? One of the things I like to do is look at what attacks are out there and what are happening and learn from history. And so when I'm doing pen testing, I want to know what's happening so I know what to test in my customer environment. And anytime we're looking at an attack in the news, it's really important to appreciate that those people are sharing that information. We don't want to be berating them, they made a mistake, but really saying thank you, because you can take what happened to them and look at your own environment and say, oh, could that happen to us? So here's an example from Sumo Logic. So I am friends with the person who used to be the CISO there, and they had an incident where someone put their keys in GitHub, and they were using a tool called TruffleHog. And TruffleHog will go out and scan your environment, and it will look for any sort of secrets. So the attacker got the keys, had access to TruffleHog, and they went out and they tried to use those to get customer data. So the article here is very interesting because he also talks about incident response, which is not what I do. So if you're into that, good story. But that story is essentially what happened. So how do we defend against that? So one of the things that I really wanted to do when I set out for writing this batch job framework is I wanted to say, I want to enforce MFA every time you run a batch job. And that was a really key thing that I want to do, because when I'm running pen tests and customer accounts, I always use a role, and I say put requirement for MFA on that role, and whatever I'm doing in their account, I always use MFA, whether it's on the CLI or what have you. And I explored a lot of different ways to use MFA to kick off a batch job, and I'm going to have all these links for you here in this slide deck when I release it, and my blog has some posts with paywall on it, and there will be a friend link so you can get to them without that paywall. So you can check that out if you want. So now let's look at Circle CI. Circle CI was another one where the developer was listening to some cool music, and there was a vulnerability in their music software. Attacker got in. They were able to get in memory the session, even though the developer was using MFA, the session tokens in memory were accessible, and also some encryption keys were in memory. So this is a little bit trickier, right? So we're using MFA, and MFA is really, really helpful, but what do we do? This is where batch jobs can help you, where you can put your critical actions like that, where there's sensitive data involved, in a batch job. Don't be running those on the developer machine. Put them in a batch job in a private environment, lock that down, and separate the people from the data, which is something that I've heard Werner Vogel say a lot, and AWS does a lot, and have that automation occur in some other lockdown area. Another thing you can do is learn about network security. I have tons of blog posts on network security, showing you how it works, down to like dissecting packets and looking at your network traffic, how to configure a firewall. If you're working at home especially, learn something about network security and how that can help you spot attacks and block attacks. So then we have SolarWinds, huge, right? And so SolarWinds is really interesting because the attackers deployed a rogue update. And one of the things about that is I went to a network security appliance vendor and I said, how are you going to prevent an attack like that? And he said, well, if some malware came down to our box, it would fail because we do a checksum, and therefore it wouldn't be able to run. So if you look at SolarWinds, more information came out after the fact. What happened was the attackers got into the build process. So after all this stuff was scanned, it's secure, and they kicked off the build process, then they inserted the malware. And then the build finished. And at what point do you do the checksum? You do it when the build's finished. So the build has malware in it. And so that whole checksum process is out the window. So how do we defend against that? My question here is, and I don't know all the details, how could they insert something into the build process if the whole network was locked down, like if it was in a batch job, running in a private network, no one had direct access? How could they get that malware in there? And there are ways, but it would be really hard. So I would suggest, really locking down networks to authorized IPs. And by the way, in my other slides that I did, I have a lot of other things you can do. I just don't have time to cover it all right now, so you can check that out. Another one was Octopus. So Okta really got sort of blamed for this, but really what happened is Okta customers were getting phished. So there's a tool called EvilJinx, and it will essentially show you the real website that you're logging into, except for the URL might be a little different. It's basically proxying that website to you. So you go to that website and you log in, and it all looks legitimate. And actually you are getting to, in the end, to the right website, but along the way you're going through an attacker server and they're stealing your credentials, your session, what have you, and then you are logged in and working and you never know what happened. And so one of the really dangerous things here is the OAuth code flow is really susceptible to attacking, where I see that. And actually Microsoft just said we're going to stop using the OAuth, it's device code flow, I should say. We're going to stop using that altogether. And so be really aware of that. How do you defend against that? Well, the person who built that EvilJinx software said they cannot steal the tokens if you're using a hardware security key like a YubiKey. So that's my recommendation if you're on the web. And my other recommendation is to use an authenticator app with the CLI. Now I know there are ways of using a YubiKey with the AWS CLI, but I recommend not doing that for reasons on my blog. So this is what I personally use at the moment. Everything's changing all the time, but that's my current approach. So as you're thinking through all these attacks, there's a couple of things I see that I call faulty security logic that you want to think about. When something is not working, often people will say, oh, let's replace it. Let's get rid of passwords, or let's get rid of AWS keys, or something like that. Sometimes you have to think about, do we need to replace it, or do we need to fix how we're using it? So for example, if you're using long-term credentials, MFA, AWS keys, you can add MFA, you can add IP conditions and things like that. So if you really need them, there are ways to make them more secure. Another thing is we're secure because we have XYZ. We encrypted everything. So you want to think about one control is not enough, and sometimes those controls are more like a speed bump versus a wall. And the other one is we have this great control, so we're good. So there may be a bypass. You've created this architecture where you have this control, but someone can just kind of go around this control and go around whatever that control is to get into your environment. Another thing I always think about with security is complexity is the enemy of security. So as we try to get more and more complex and more security controls, it's going to start breaking down because someone's going to make a mistake. People are going to try to get around it. So you want it to be simpler, but on the other hand, if it's too simple, it's not really doing what it's supposed to do, right? So if I don't want to use a key when I leave my house because it's too complicated, well, that's not really smart because someone's going to try the door and just break in, right? So we're always trying to balance these things out. And this is where I kind of got stuck when I was writing my blog series. I kind of stopped writing for a while because I had built something that was so complex. I'm like, no, it has to be simpler. So how do I meet my objectives from a security standpoint, but make it simpler? So it's kind of this continuously iterative approach. And the other one is, if I had more time, I would write a shorter letter, Mark Twain. I would write you a shorter presentation. I'm trying to tell you a lot of things in a short amount of time. But one of the things I always say is every line of code is a potential bug. So take a look at your code base. Do you really need all that code? How can you streamline it? Depending on, especially using AI, it'll sort of duplicate code all over the place. You want to streamline that, not have so many places to fix if there is a bug. And the other one is real-time third-party code injection. I have a blog post on that. So there are a lot of cases where third-party code has been an injection point for malware. So my question is, do you need to run that third-party code, access that third-party API, or can you bring that internal and host it yourself and scan it and make sure that's not changing along the way, like polyfill.io, if you guys are familiar with that, is an API I saw a lot on pen tests, and all of a sudden it was taken over by another group and it somehow supposedly had malware in it. They say it wasn't, but those are the things you want to be careful with. I talk a lot about abstraction on my blog, so I'll let you go read those. I'll have links in here, but essentially you can think about ways you can abstract out the things you're doing into common components, and that will help you with security. You'll have less to manage. If you have some code to fix and you have abstracted it to a common class, you have one class to fix. So think about ways you can use abstraction. And I used abstraction as a way to build my batch jobs in a repeatable, secure manner. So there's a lot of security considerations when we're looking at batch job security. I have a list of them here, but some of the things I thought about is, I want to have one MFA every time. So when you run the batch job, MFA is required. You want to make sure it's in a private network if you can. Maybe you have it connecting to certain resources, so it's going to reach out to some things, but you want to really make that network as restrictive as possible. And then you can use KMS a lot for encrypting the data, and you can use KMS in conjunction with your IAM roles, so you can restrict who has access to use which keys and so on. And there's a lot more here, but you can take a look at that. All right, so I've been doing a lot on my blog with AI and vibe coding, AI agents, things like that. And it's really fascinating because you can put something in there and say, give me a CloudFormation template. It's really great. So I put something in, I said, give me a VPC network, and the template came back. It was pretty cool, right? And then I said, I have this CloudFormation or CloudFront website running in an S3 bucket with all these different configurations, and give me all the templates for that. Well, then it kind of broke down because it's a lot more complex, right? So when you're thinking about AI, you want to understand that it's going to do some things really great, but at the end of the day, you still need to check it. And a lot of that has to do with the fact that it's a predictive model. So I like to say when you're using, if you've ever been on social media and someone says, go put in these words into your phone, and whatever 3 words come up next, that's what you are. And so it's trying to predict what the next words are on your phone, and what comes up on your phone is different than what comes up on someone else's phone, and maybe even what comes up on your phone is different like 2 other times. So when you're thinking about using AI, this is sort of a new threat. It's a predictive model. You probably don't want to be using that for bank statements, but there are a lot of use cases where it's appropriate. If you do use it, you want to check it. I've been doing a lot of research in this area too. The way the models work, they can put together tokens in strange ways that the models understand but are actually not correct from a human perspective. Like if it can handle French and German, let's say, it could bring it together 2 tokens from different languages and put them together. I actually had this happen with YAML and JSON when I was doing CloudFormation templates. At some point, Amazon Q was giving me this mishmash of YAML and JSON. It was not right. So be aware that can happen. A lot of people are also jumping on the AI bandwagon, and they're not doing all the traditional security controls with their agents. And like I said, an AI agent is essentially a batch job. So all these things I'm talking to you about are still applicable in AI. And I like the last talk on MCP servers as well, because out of the box, they don't have authentication, right? So they were talking all about an open source tool AWS put together to do that. So a lot of things to consider there. I can quite cover it all, but just as a summary, batch jobs can help you process data more securely because you can put your processes into a secure environment and really lock it down and keep them away from the developer machines, for example. And then you want to make sure that your inputs and outputs and your processing are all secure, like all the way through. What you're putting in, what you're getting out, what you're processing in the middle, all those things need to be secure. AWS provides you all the services to do that, but you have to use them effectively. And that's kind of what I was going through on my blog, where I was trying out different services to do different things to implement this system. I think about the cost, how could it be attacked? I have things on privilege escalation out there, and a lot of different attacks that can happen on AWS. So yeah, base your batch job security architecture and whatever you're building on a threat model. Look what the threats are, look what's happening to other people, and figure out how you can design something that protects against it. Thank you.